Exit signs connected to a night light circuit powered by a standby generator are generally considered sufficient as a standby source of illumination for egress lighting, according to the National Fire Protection Association 101 Life Safety Code. The setup means a battery backup for exit signs isn't necessarily required. Now, when it comes to combining exit lights and egress lights on the same circuit, it is generally a violation of NFPA 101. The code mandates that egress lighting must be on a circuit separate from other lighting. This separation is essential to guarantee that egress lighting remains illuminated even if there's a power failure affecting other circuits. Egress lighting's primary role is to guide individuals to safety during emergencies. By ensuring it's on a dedicated circuit, you prevent a local lighting circuit failure from plunging escape routes into darkness. Exit signs, on the other hand, serve as visual indicators pointing to exit locations. They can be powered by a standby generator or a battery backup, ensuring they meet code requirements for standby illumination. The reason for this distinction lies in the critical function of each type of lighting during an emergency. Egress lighting provides the essential illumination for navigating escape paths, and its reliability is paramount. The Life Safety Code, specifically NFPA 101, provides detailed guidelines for emergency lighting systems. The fundamental principle is to ensure that occupants can safely evacuate a building during a power outage or other emergency situation. Emergency lighting includes both exit signs and egress lighting, but their functions differ. Exit signs clearly mark the path of egress, while egress lighting illuminates that path. The code addresses the power sources for these systems to guarantee their reliability. Standby generators are a common solution for providing backup power to emergency lighting systems. They automatically start when normal power is lost, providing a continuous supply of electricity. Battery backup systems offer an alternative power source, but they have a limited runtime. The specific requirements for battery backup depend on the type of occupancy and the applicable codes. The Life Safety Code emphasizes the importance of maintaining emergency lighting systems in proper working order. Regular inspections and testing are essential to ensure that the systems will function as intended during an emergency. These inspections should include checking the functionality of the automatic transfer switch, the generator, and the battery backup system. Another key aspect of emergency lighting is the illumination levels. The code specifies minimum illumination levels for exit signs and egress lighting to ensure that they are clearly visible during an emergency. These illumination levels must be maintained throughout the required runtime of the emergency lighting system. Furthermore, the placement of exit signs and egress lighting is critical. Exit signs must be located at all exits and along the path of egress, clearly indicating the direction of travel. Egress lighting must be distributed throughout the path of egress to provide adequate illumination. The code also addresses the type of lighting fixtures that can be used for emergency lighting. The fixtures must be listed and labeled for emergency lighting use and must be designed to withstand the environmental conditions in which they are installed. In addition to the Life Safety Code, other codes and standards may apply to emergency lighting systems, such as the National Electrical Code. These codes provide additional requirements for the installation and wiring of emergency lighting systems. Compliance with all applicable codes and standards is essential to ensure the safety of building occupants during an emergency. Regularly review and update your knowledge of these codes as they can change. Consider the implications of using LED lighting in emergency systems. While LED lighting offers energy efficiency and long lifespan, it's important to ensure that LED fixtures are compatible with the emergency power system and meet the required illumination levels. The color rendering index of emergency lighting is also important. A higher color rendering index makes it easier for occupants to distinguish colors, which can be helpful during an evacuation. Conduct regular drills to familiarize occupants with the emergency evacuation procedures and the location of exit signs and egress lighting. These drills can help to improve the effectiveness of the emergency lighting system. The design of an emergency lighting system should take into account the specific characteristics of the building, such as the occupancy type, the the building size, and the arrangement of the means of egress. A qualified electrical engineer or lighting designer can help to develop an emergency lighting system that meets the specific needs of the building. Remember that emergency lighting is a critical component of a building's life safety system, and it's essential to ensure that it is properly designed, installed, and maintained. The cost of emergency lighting is a relatively small price to pay for the safety of building occupant. If you have any questions about emergency lighting requirements, consult with a qualified electrical engineer, lighting designer, or fire safety professional. Stay informed about the latest developments in emergency lighting technology and codes. Attend industry conferences and seminars to learn about new products and best practices. Share your knowledge and experience with others in the industry. By working together, we can improve the safety of buildings and protect lives. When installing or modifying emergency lighting systems, obtain the necessary permits from the local building department. This will ensure that the work is done in accordance with applicable codes and standards. Keep accurate records of all inspections, tests, and maintenance performed on emergency lighting systems. These records can be helpful in demonstrating compliance with code requirements and in identifying potential problems. Provide training to building staff on the operation and maintenance of emergency lighting systems. This training should include instructions on how to test the systems, how to replace batteries, and how to troubleshoot common problems. The use of photosensors and dimming controls in emergency lighting systems can help to save energy, but it's important to ensure that these devices do not compromise the performance of the systems. Photosensors should be carefully calibrated to ensure that they do not turn off the emergency lighting during a power outage. Dimming controls should be designed to automatically switch to full brightness during an emergency. The emergency lighting system should be designed to operate reliably even in extreme temperatures. Cold temperatures can reduce the battery life of battery backup systems, while high temperatures can damage lighting fixtures. In some cases, it may be necessary to provide supplemental heating or cooling to protect the emergency lighting system. The emergency lighting system should be protected from physical damage. Lighting fixtures should be installed in locations where they are not likely to be struck by vehicles or other objects. Wiring should be run in conduit to protect it from damage. The emergency lighting system should be designed to be easily accessible for maintenance and repair. Lighting fixtures should be mounted in locations where they can be easily reached for bulb replacement. Battery backup systems should be installed in locations where they can be easily accessed for battery replacement. The emergency lighting system should be compatible with other life safety systems in the building, such as the fire alarm system and the sprinkler system. The fire alarm system should be designed to automatically activate the emergency lighting system during a fire. The sprinkler system should be designed to not obstruct the emergency lighting. Consider the aesthetics of the emergency lighting system. Lighting fixtures should be chosen to complement the building's architecture. Wiring should be concealed whenever possible. The emergency lighting system should be designed to be as unobtrusive as possible. Obtain input from building occupants when designing the emergency lighting system. They may have valuable insights into the best locations for exit signs and egress lighting. They may also have suggestions for improving the aesthetics of the system. The emergency lighting system should be designed to be flexible and adaptable to changing needs. As the building is renovated or reconfigured, the emergency lighting system may need to be modified to ensure that it continues to meet code requirements. The design of the emergency lighting system should take into account the needs of people with disabilities. Exit signs should be located at a height that is visible to people in wheelchairs. Egress lighting should be designed to provide adequate illumination for people with visual impairment. The emergency lighting system should be designed to be energy efficient. Use LED lighting fixtures and dimming controls to reduce energy consumption. Consider the use of solar power to provide backup power for the emergency lighting system. The emergency lighting system should be designed to be environmentally friendly. Use lighting fixtures that do not contain hazardous materials. Dispose of batteries properly. The emergency lighting system should be designed to be cost-effective. Consider the life cycle cost of the system, including the initial cost, the operating costs, and the maintenance costs. Choose lighting fixtures and components that are durable and reliable. The emergency lighting system is an investment in the safety of building occupants. The system should be designed and installed to the highest standards. The system should be regularly inspected and maintained to ensure that it will function as intended during an emergency. Now consider the importance of documentation. Maintain comprehensive documentation of the emergency lighting system, including drawings, specifications, and maintenance records. This documentation will be invaluable for future inspections, repairs, and modifications. Always prioritize safety when working on emergency lighting systems. Ensure that the power is turned off before working on any electrical components. Wear appropriate personal protective equipment such as gloves and safety glasses. If you are not qualified to work on electrical systems, hire a licensed electrician. Remember, the primary goal of emergency lighting is to provide a safe and reliable means of egress during an emergency. Your diligence in designing, installing, and maintaining these systems can save lives. Think about the advances in smart building technology and how they integrate with emergency lighting. Some systems now offer remote monitoring and control, allowing for proactive maintenance and faster response times during emergencies. Consider the benefits of integrating emergency lighting with building management systems to enhance overall safety and security. It's also worth noting the evolving regulatory landscape. Stay updated on the latest changes to building codes and standards related to emergency lighting to ensure compliance and maintain the highest levels of safety. Lastly, never underestimate the power of education and awareness. Share your knowledge of emergency lighting with colleagues, building occupants, and the community. By promoting a culture of safety, we can collectively contribute to a more secure environment for everyone.